Hi class. So what we're going to look at now is ring strain. And what this talks about is as you start to make cyclocompounds, so let's take a 3-carbon molecule, and where we're going to put them is in these geometric shapes. So if you remember, there's a carbon at each one of these. So there's a carbon here with two hydrogens, and kind of the same all the way around. Right? And as we go forward, that has 3 carbons, so it's a 3-membered ring. We can do cyclobutane, which essentially looks like a box or a square. Cyclopentane looks like a pentagon. We can get a 6-membered ring, which is a hexagon, and so forth, right? And we can even go to 7-member rings. And let me try, it's a little harder. I don't do it as often. It's supposed to be 1 carbon. And so what I'm going to do real quick is just highlight the carbon so then we can go back and talk about each of these. So remember, at each one of these apexes, there's a carbon, and it's the same for each of these other ones. And then also, don't forget that there's the amount of hydrogens needed to give that carbon 4 bonds. And so for each of these, it's typically 2 hydrogens. Right? And we can do the same all the way around each of these. All right, now, what I want to highlight is that if we're looking at this, we can guess what this bond angle is, right? So typically in a triangle, right, if we're looking all the way around, this is going to be 60 degrees. All right, now that's important because if you come look over here on the right-hand corner, let me get a less bright color. If we look at our carbon, and let's look at methane, and remember, it has this tetrahedral shape with the wedge and dash kind of pointing things towards us and away from us. This bond angle is actually 109.5 degrees. And so what I want to highlight is look at the difference between this, right? We're forcing this carbon, which is still trying to be tetrahedral, to bend to a 60-degree angle when it really wants to be 109. And so that huge difference is what causes the ring strain here. And so you get some really, really bad ring strain exactly because of that. So it's this ring strain that causes this ring to be unstable and tends to be really reactive or easy to open. Now, if we go to the next one, if you have a right angle, if you remember from your geometry classes, this is going to be 90 degrees. All right. And as we get to 90 degrees, the difference, and I'm going to put it right here, 109.5, is a little bit smaller, right? So we've gotten a little bit better. 60 versus 109.5 is a huge difference. 90 isn't there, but we're getting closer, all right? So in terms of ring strain, kind of the worst, still not good, but we're getting a little bit better. Pentagons, as you can see in this picture here, we've opened this angle up a little bit. Still not quite there, but we're getting closer. When we get to this one, I'm going to put a star because then we actually do get to our 109.5. So one of the things I would highlight is that in terms of ring strain, we're going to keep getting better this way. So I'm going to write the best and then the worst. All right. So your 6-membered ring, you guys should put a star by because that's the most stable. So a lot of times I'll ask you which of these rings is the most stable or has the least amount of ring strain. What you want to, it should jump out of your mind is a 6-membered ring. Now 5 isn't bad, and so we'll actually see these 2 rings the most. Right? So 5-membered ring is still good. Right? So I'll even write that just to make sure it's clear. It's still a good ring, but this one's the best. All right, the other one that I want to highlight is down here we have a 7-membered ring. And you would think this early trend kind of shows us that, oh, as the rings get bigger, we just keep getting better. This is kind of the apex. As we start to get bigger, we start to go backwards. And so this one isn't as good as these two. All right, and so just because it's bigger, then you start getting these weird angles where it wants to open more than it should or it has to bend funny. Once you get to a 6-membered ring, you're kind of the most stable because you really optimize these rings in terms of the bond angle. If you look at a 6-membered ring, if we think back to our Newman projections, these hydrogens actually line up really nice where they're anti. So if you remember, this is where we don't have any of those bad steric interactions. So they line up really, really nice. So they're all staggered conformation. So you get a really nice interaction between each of these. And it's a little outside the scope of this class, but as we get bigger, they don't necessarily get better. All right, I hope this was helpful.